Welcome to another CO2 Monday and the Refrigeration Mentor podcast. I'm your host, Trevor Matthews. And today I got a good guest. Actually, we had a good conversation on Friday about this podcast and a wealth of knowledge. Been in the industry for over 40 years, 25 years in training, just developing young minds and definitely a lot of leaders throughout the years because he's been involved in so many trainings and taught so many people around North America, which I'm super excited to get into this conversation because Heatcraft is starting to get more into the CO2 side of the industry, and I'm super excited to dive into this. So my good friend here, Don Fort, he's been with, how long have you been with Heatcraft?
Heatcraft about 4 years.
4 years. And so that,
Mhm.
I'm sure that was a huge learning curve, but you've been in doing training for about 25 years, is that correct?
Absolutely. Yeah.
Yeah.
So not a new area of expertise for sure.
I love it. I love it. Why
And
don't get,
the good thing is I'm still excited about it,
yes,
man.
that's a bit.
What a
I've
nice
seen
intro.
I've been
Thank you,
doing
Trevor.
some the little research on you, and I see lots of pictures online, and you're always smiling, loving the training. So that's what it's all about when you're sharing knowledge, Don. It's all about that, right? Loving what
Yeah.
you do. Why don't you give a little intro to everyone on your a little bit about your background and what you're doing right now with Heatcraft?
Well, as you said, Trevor, been in the HVACR industry for nearly 40 years. I mean, time really flies, and so about 25 years of that, of course, actually teaching. So everything from the small stuff, like when I worked at Sears back in the day when they actually had some great training for technicians in the field, but and then moved that to from there to LG. So got a lot of experience about inverter technology with LG. I actually helped them start the HVAC business in the United States back in 2004.
Wow.
And so,
Wow.
hey, I remember when we only had 4 people in the organization. Now they probably have about 250. So it was a learning curve because, hey, you don't know what you don't know, right?
Yeah.
But nice to have that. So now switching back to refrigeration for the last 4 years with Heatcraft has been a nice change of pace, and especially knowing that there's so much work to do to help people get comfortable with the technology, with the processes around the refrigeration process, the cycle. The good news, the physics don't change.
Yeah.
Just how we monitor and control that might change and be adjusted. But hey, it's all a matter of getting comfortable, right? And get as many people comfortable with the process as we can.
Yeah. And I like what you said. Like even 2004, you started with LG, and that's when you were working with the inverter technology. So it's not new when we're seeing it on all these new pieces of equipment, right? So
Yeah,
this is the
right.
big thing we need to talk about more in refrigeration because they're going to see it more. Because then, on the heat pumps and then the package unit, not the package units, but like inverters and stuff like that. You've seen them for years and years and years, and now we're starting to see more in the refrigeration side. So we need to just start to get more used to this stuff because electronics are here.
And it's not going away, especially when governmentally they're driving us to be more and more efficient. And there's just so many so many tools in the toolkit that you can actually utilize to get the efficiencies where they need to be, right? So,
Yeah.
yeah.
And that's what one of the things that I've been noticing over the last few years, well, probably about 5 years when I was working with Emerson, just starting to see the regulations from the manufacturer side. So you work for a manufacturer. As a technician, I never seen a lot of that stuff. But when I get into the manufacturer, they have to be up to speed on what's going on with all the regulations. And I
Yep.
remember at one point, all the refrigerants were starting to change, phase down or phase out. And then all of a sudden the DOE started to come in. Well, you need to have this much efficiency. So all these different changes all happening at different times, but manufacturers have to like weave in and out of this, and then they have to spread that knowledge out to the industry, to the wholesalers, to the other manufacturers, to the technicians and contractors in the field. So it's like there's a lot on the go out there in the field right now.
There is. And we're not driving that necessarily, but we have to make sure as a manufacturer that we have options for the technicians to actually apply the actual projects out there in the field. So we have to find things that work for your customers out there. So, hey, it's an ongoing thing. It's a moving target, and we want to keep moving with it.
Yeah. Yeah, no, that's awesome. Okay, let's start. You've been at Heatcraft for 4 years. What kind of training and development have you been doing over the past 4 years with Heatcraft? What was your focus?
Well, hey, this is CO2 Mondays, right? So more and more attention is being placed on natural refrigerants. Back in the day before synthetics were all the rage with our 400 series refrigerants, hey, natural refrigerant was a thing. So you had two choices basically. You had CO2 and ammonia.
Yeah.
Now we see things coming full circle because as things like you mentioned just a moment ago, as refrigerants are being phased down, phased out, just think next month, last time you can have R404A actually manufactured as a fresh new refrigerant, that's no longer on the table. And that was a very popular refrigerant, still is right
Yeah.
now. A lot of equipment has 404 in it, but now we have to find alternatives to your HFOs and HFCs. So that's why we have to get our arms wrapped around CO2. So what we've been doing, last year we introduced just a CO2 101 training. So
Nice.
what's different? You remember back in the day, this was like in the 90s, like 1992, when R12 was done away with. And remember, technicians were just all over themselves with R134A. Oh no, it's so hydroscopic. Oh no, I can't finish the seal system long enough before I actually have contaminated oil in my compressor. How am I going to do this? Well, who says, here we are, fast forward to 2022, who says anything about being uncomfortable with R134A now? No, they don't, but we fear what we don't know, what we don't understand. And that's why we have to train people. So now giving our attention to CO2, well, what's different about that? Well, as soon as they see what the operating pressures are, 1,055 PSI,
Yeah.
I'm using a gas cooler instead of a condenser. Wow, how am I going to deal with that? So we took it upon ourselves to let's do some introductory information. Let's first of all talk about why the change, because when you think if CO2 is the reference gas as far as global warming potential is concerned, and it's a reference point of 1, just think about R449A, which is another popular refrigerant, right? That has a warming factor of 1,397. So it's 1,396 times more insulating value in that gas than CO2. Well, what do we know? We know we're not going to stop having a need to refrigerate and freeze things. So the most we can do from a technician's perspective, even from a manufacturer's perspective, is let's use less of the bad actors and more of those things that don't have such a heavy impact on our environment. And so that's why another big reason why we need to all get comfortable with working with CO2 in general. So we have the 101 class that we launched last year. Now we're going to have 2 steps of certification. One, if we can just get people comfortable with all the steps to do a pre-startup, and then how do you commission a CO2 system properly? And then the second phase, once I get that out of the way, how do I troubleshoot that CO2 system? Because when you think about that, remember the refrigeration process doesn't change, right? So we still have to cause a change of state by manipulating pressures and temperatures, right? That's just the name of the game right now. So still having transducers and thermistors in the mix, so they're keeping tabs on my seal system. How do I troubleshoot that? And then depending on the controller that you like, I personally like the Danfoss controllers. So their system manager and their pack controller is very good for CO2, right? So how do I set those systems up and actually troubleshoot the individual components efficiently? So how do I work through, what's my SSO? What's my sequence of operation? And how do I work through that as I try to drill down and find the problems in the particular system I might step up to and work on. So that's coming in the future as far as that level of training. But that's what we have in mind, just to try to take the bull by the horns, if you will, and to actually get people comfortable with these refrigerants. It's not new. CO2 has been around for Well, it's been around since the Earth's been around because it's a natural
Yeah,
refrigerant.
yeah, that's a good
It's been
point.
around longer. It's been around longer than any of us,
Yeah.
right? So learning to use that as a refrigerant now, that's going to be the key moving forward for
Yeah.
us.
So I only recently learned, probably in the last couple of months, that Heatcraft been building CO2 systems for a long time, because you guys are part of a larger organization, Linux International. And Linux International, when I was out at Chilvint, I seen a bunch of their CO2 equipment. So you guys been in the game for a really long time, because
Yes,
I believe a few years ago you guys had Kaiser Warren underneath your banner. I don't know if you still
we
are,
did.
and you guys
Yeah.
built a lot of CO2 equipment with them. Now you're moving into more of your own um, brand and design of CO2 systems. Is that correct?
It is. I mean, we have a very, very rich engineering capacity. We call it our COE team, so Center of Excellence. And they're responsible for engineering product that we can use as large as you can imagine. We'll build those CO2 racks from scratch just to meet all the engineering specifications for a given project, right? See, but along with that, we have to also pass on that knowledge. Okay, so it's built now. Now, how do you start this equipment? How do you maintain this equipment?
Yeah.
How do you service the equipment, right? See, so that's closing the loop on that, so we can just have a lot of projects out there that are successful, that work well, but it's man-made, so it's liable to need some maintenance and even some service from time to time, don't you? Well, how can you do that successfully and safely,
Yeah.
right? So
And
that's
I
the
like that. I like that a lot, because I know on Friday we were talking about that you guys are, like you said, you're planning to build these certification training programs for your customers. And
yeah.
you said you're doing, I believe you said you're starting out with a pilot to try it out with some of your top customers and grow. What is, are you involved in building this program? I'm assuming there you got a lot of involvement to grow this program. And what's the steps you are taking to really help your customers with these certifications in the program?
Glad you said that, Trevor. Yeah, well, as far as my involvement, it's my baby. I've got to design the
Yeah.
program. And you're right. We are actually this week having a beta test. So we're having customers come in. We're gonna present the beta test material. We're gonna do the hands-on elements of that material. We're gonna get their feedback. So because you know how it is, if you
Yeah.
try to engineer a new program, it might work well in your head,
I
but
know all
now
about it.
when I try to teach that back to somebody, does it make sense
Yeah,
in,
I
in
know.
that order that I think it is? Or do I need to tweak that a little bit? So that's the whole point of beta testing these kinds of
Yeah.
programs. So we're going to have real life folks come in. We're going to have some people from some control manufacturers come in so we can get some bounce back with them and field any questions the customer may have. And based upon those findings, we'll tweak what we have to make sure we have a program that's solid and that's meaningful for those who want to spend some time with us in training. So
Yeah,
that's,
no,
yeah.
and I really like that, because you got to it's a continuous evolution in training. So
It,
you'll do this beta test, and I've done so many years of training, and I've seen I got to tweak it a little bit here. I can see there's more interaction here. Oh, this was very helpful. You can see in either the marks that they received or the service that they gave back, is that these are the areas that we need to focus on. And I know in a lot of trainings I do that especially for CO2, is a lot of the role playing stuff. That's what I find has been working in a lot of my trainings.
uh,
Because the way it used to be done, and I even used to do it, is you sit down, you talk to them, and you're just shooting out lots of knowledge. But are they absorbing? Do they remember it? Are they comprehending it? Can they explain that properly afterwards when they're leaving? So I noticed my trainings are continuing to evolve even now, because how do you impact them the most, especially with CO2, because there's so many dynamics to it. It's not like,
yeah,
yeah, the refrigeration cycle is the same, but where are you at? Are what side of the system are you? What time of the year is it? All these other
yeah.
factors that are a little bit different, than your standard HFC, HFO blend systems.
Yeah, and it's so good you mentioned that too, Trevor, because that's one of the things we have to get people comfortable with. Because the transcritical portion for CO2, when you look at the pH diagram for that, it's just 87 degrees. If you bump over that, now you're at 88 degrees. Now that's transcritical. So now that's the point at which we can't have, normally the contractors are used to having, when I get that refrigerant outside at that condensing unit, they're looking forward to do, as the name implies, to condense.
Yeah.
But at that pressure, which is 1,055 psi, not going to condense. The most I can do is cool that gas. So that's why they call that, at that point, a gas cooler instead of a condenser. It's in the same location, even in the seal system as the condenser would be, but because of the pressure, guess what? It's not going to condense.
Yeah.
And that's why I have this flash tank. So now I have to actually to meter the amount of refrigerant in that flash tank to make it lower in pressure, so I can have that as a usable liquid form. And now I can get it to behave like any other refrigerant. So I can have my low temp evaporator. I can have my medium temp evaporator after that, but we have to make sure that we have that cycle sound. And that's where attenuating the flash gas bypass valve and that high pressure valve come into play.
Yeah.
We need to keep that around, less than 580 psi to get it usable, so I could actually use it to actually do some cooling, right? See, so doing that, keeping that balance and helping people appreciate what they need to do. And when you step back and look at that, Trevor, hey, this is not as difficult as I thought it was going to be. I'm less scared about this now because I know what to expect. And so that's the beautiful thing about training people and having people in. Come on down and let's do this. And the more we get to do that, the more people we have in the craft, in the trade, that's doing the right thing for the right reason and getting the right results. And that's getting it fixed.
Yeah.
And moving on down to the next project, right?
Yeah, no, I do really like that. And all the trainers that I deal with and I work with, and I can see that you're super passionate about training, is that on the CO2 side, everyone just so helpful. All the trainers that I know in CO2, they just really want to share the knowledge so the technicians feel comfortable and confident, because we've been there. When I started out with CO2, I was pretty edgy at first. I'm like, what is going on with this system? Not understanding on how it worked. There's all these extra electronic components. And if you've never seen electronics before, it's definitely overwhelming and intimidating. But if you take your time and you read the manuals and you talk to a few people, that's really important. I like when you got back to the high pressure and the bypass valve. Those valves there are, I still think, even with a lot of the technicians that understand CO2, still don't really understand what is going on in them and how they are functioning in all these different zones depending on the manufacturer. And I'm really glad that you guys have the control manufacturers there during the training, because that's going to really help out. Because I see it in a lot of my trainings and a lot of trainings I've been on, is that the high pressure valve and the bypass valve, like something we didn't see before. We haven't really used them, and just visualizing what's going on in that system makes the world of difference. And I think I think CO2 is really what helped me become better at refrigeration. And I think I could start seeing what's happening inside the pipe. After I looked at the enthalpy diagram, I had the pressures, what's going on in the pressures. I had the enthalpy diagram. I had the piping diagram. And all of a sudden, it's like everything started to make sense. And I'm like, well, this is so... And it helped me for all the HFC stuff I was doing, because, you see the pipes there and it's getting cold and you touch it and the airflow. But it's when you can feel like I know what's happening inside there. That's where it starts to click. And so that's what I'm trying to make happen for other technicians out there.
Yeah, and some people can think abstractly a little easier than others, but you gotta, to your point, put yourself inside that pipe. If you can't get inside the pipe, you're not going to be very good at troubleshooting, right? But now, knowing about how these components work and really breaking that down, because when you think about that, okay, so I've got an EEV, but what does it do? It just opens and closes a path for refrigerant flow. That's all it does. Now, how open or how close? Well, now that's what the transducers and those thermistors that are monitoring those pipe temperatures, that's what they're there to kind of give you the feedback, to give the controller feedback, so it knows how open to open and how close to close. That's all it's doing. So you have so you think about that, the valves can only be open or closed. right? You know,
Yeah.
and switches can only be on or off.
Yeah.
So we don't have that many choices there, but now those nuanced values, especially for EVs, let the controller do that. We just want to understand that it needs to happen, but we can't know where. If I had to manual open and close that valve to try to keep up with those pressures and keeping that in a usable range, PSI wise, hey, I would fight a losing battle. I have to have something that can keep up with those things very quickly, right?
Yeah.
And that's what the controllers are for, you know, and knowing that that has to happen. And the ultimate goal is maintaining a certain pressure on the high side and the low side, what's acceptable when I need to lift those the low pressure compressors up to the medium temp compressors. Okay, so now all those things are working together. And like you mentioned, knowing that that has to happen, that's half the battle. And that's why it's so important for us to get a good, clear picture of the SSO, the sequence of operation. So that's gonna, or SOO,
Yeah.
sequence of operation,
Yeah,
right?
no, and I totally agree with you. I've done years of troubleshooting on electronic controllers and valves, and it was surprising to me where a lot of people ran into issues. It was because they weren't reading the instructions, trying to
Oh,
figure out
no.
electronics, trying to figure out electronics without getting into the manuals and understanding those components. And I love what you said there, understanding the components, each and every one. And it takes a long time. I'm still learning components on HFC systems. You know what I
Oh,
mean?
me too, me too.
And then now with CO2. So, but with the electronic controls, like you said, it's open or close, opening or closing. But we need to program it on how to do that. And that's where you need to understand every single parameter. And does this take a long time? Yes, it does. Is it hard? Yes, it is. But can you do it? Yes, you can. It takes
Yes.
time and learning, because I really like that, understanding each component, and those technicians and even those manufacturers and those people that work on all these components. The ones that continue to grow are reading the manuals, finding issues in the manuals. I love that. I love when people would call me up when I was working in, there's something wrong in this manual. There is. Let's go back to the application
Yeah.
engineer and let them know so they can update that and fix that. Don't get mad and all frustrated with it. Be like, good, I'm helping out another technician down the road. When they read this, they'll understand it a bit better.
Yeah, I like that too, Trevor, because those are really living documents because they're going to change and nobody's perfect, you know. So there might be something passed because most of us are on deadlines. And so, okay, you got to have this out by X date. Okay,
Yeah.
ready or not. And
Yeah. Yeah.
sometimes it's not quite ready for prime time. But the good news is it doesn't have to stay wrong. With
Yeah.
that kind of feedback, like you mentioned, we can make those changes and make it even more usable over time, right? We
Yeah.
can do that. We
And that's
want
what
to
I
do
did.
that.
I found so many manuals. I email people now with manuals that I read, and I let them know, like, I think this could be wrong. Can you just correct me if I'm wrong? Because once again, people change roles and change jobs and deadlines. So don't always just throw the manufacturer's information under the bus. Maybe it was done by a mistake, right?
Might have
Uh,
been. Yeah, for
yeah.
sure.
So that's great. So we talked about, understanding component, understanding these electronic valves. So you're going to be doing this beta test next week in your training. What are some of the things that you're looking forward to in the beta tests for the CO2 program and certifications?
Well, you know, like you mentioned, Trevor, being passionate about this industry, just to see those light bulbs come, I want to see light bulbs come on in their heads, right?
Yeah.
And I hope it does, because that means that you've done something right to do
Yeah.
that. So I'm looking forward to that. I'm looking forward to really confirming what I think we have put together is going to be something useful. I want
Yeah.
some validation for that. And so that's going to be really good for us to see how it's going to be accepted. And also try to determine what's the right amount of hands on, because everybody likes to touch things. You know, it's a proven fact in adult education that we only remember about 20% of what we hear and about 80% of what we touch. So
Yeah.
for me to get the best chance of transferring the most knowledge, I want to allow times more touch times, for that, for the students, right? And if we can accomplish that, well, what's the right mixture? And then the next thing is, how many days can we do this credibly in a day, in 6 hours of training? Do we need to bump that up to a second day, maybe having a total of maybe 14 or even 16 hours of education to get it where it needs to be, so people can feel confident in it? And if we can, because time is so valuable. We have too few people doing the work, too few people that are really expert at the work, right? So that means their time is of the essence. And so, okay, we don't want to spend too much time, but we do want to spend enough time for you to actually get something out of this, right? And so where's that balance? Finding out what the balance is. And like you mentioned earlier, Trevor, well, how do you know how much they're taking away? Well, yeah, there's a final exam. And so let's see how well they do. And if we see a trend of the same questions being missed, and that might be an indication to me that I need to beef that portion of the educational process up, to do a better job the next time. And so that's a process. It's something that's going to take time. Like we mentioned, CO2 has been around for a long time, but because of global warming, some things that are coming more to the surface as far as the need, well, then it's going to be more and more urgent for us to do more and more, provide more and more opportunities for people to learn about this and move forward, right?
Yeah. No, I totally agree. Like, we need hundreds of more trainers out there teaching refrigeration, and I love hearing and meeting more just like you. So this training, do you guys actually have a CO2 trainer that will be running at your facility for them to look at and touch? And
well, the good thing about doing this at our office in Stone Mountain, Georgia, is that that's also where our R&D center is.
Awesome. Yeah.
So we have an Echo2 boost system that's actually up and running. Actually, we have two of them that are up and running right now. So yeah, so you have real life experience on these. We have one of them we call the Frankenstein, because it's got every whistle and bell that you can imagine. So the ejectors, the 5-port ejectors, that are out there to kind of manipulate, using the Venturi effect, the pressures in that CO2 system, right? And then outside, okay, so depending on where in the country that we're going to have these systems located, in your higher temperature, ambient-wise areas, you might need some assistance to get that gas cooler down to a suitable pressure, right? So you might have to have an adiabatic coil outside there. It's going to take advantage of some evaporation to get those pressures down, because, hey, remember, temperature and pressure are directly proportional. One goes up, the other one has to go up with it. One goes down, the other one has to go down with it. So finding that sweet spot to get that to work, that's what it's all about. That way, if we do that, we can actually have CO2 systems in more places than they would be if you didn't have those additional components that are available for you. So that's something that we're doing there. I'm pushing to get, I wish I could get it quicker, but I'm going to have one in our training room, an actual, besides in the R&D lab, another trainer that's right there. So we can, as we have those component discussions, we can actually look at the hands-on elements right there on the CO2 rack that's inside the training room. So, that's I'm salivating over that, but it's there, but it's not in the space I wanted in yet. So just
you'll get it.
By the time we have this open past the beta test, it will be in the room.
Yeah, for sure. I think one of the best things that for your program, because I've done lots of CO2 trainings on trainers and stuff, is having them go through the system with a P&ID diagram and step-by-step understanding where each component is. I don't think this is done enough in the industry. It needs to be done more in trade schools and colleges. I'm telling everyone about it. This is what I do in my programs. I tell everyone, you got to get into these piping and instrumentation diagrams, and you got to be training off it, because all of a sudden you get to a point and all of a sudden, what is this? I don't know. Good.
And where
That's
is this?
Great when you don't know. That's good. This is where we can have a conversation, because I don't know what it is either. So let's find out together. You know what I mean?
Oh, yeah, absolutely.
That's how it is. And that's how I learn. So, and I think having those examples in your program will really help out. Having them getting up there and find, what is this filter? What? what this doesn't
Yeah.
make sense. I've never seen this before. And it makes
And,
them think.
and really, that's a good point, Trevor, because although P&ID symbols are pretty well uniform, some diagrams differ from manufacturer to manufacturer.
Yes, they
So
do.
since we build our own, we have our own P&ID nomenclature that it'd be
Yeah.
nice for them to get to know, what does this mean? You know, what does that symbol mean? And to your point, where is that on the actual piece of equipment I'm going to be servicing? Because
Yeah.
there's some valves, there's some pop-off valves that you have to know, well, where are they? Because if they've popped off a couple of times, guess what? At some point, I'm going to have to blank those off and replace them because they're no longer useful in the system. So where can I find that? Well, if you know how to read the P&ID, you can run the map and find them, right? Those
Yeah.
particular ones. Yeah.
And I've been working with lots of contractors now too, getting them and technician, getting them blown up and putting them in the rack rooms, even of regular HFC stores and CO2
Oh,
stores, getting them, put it on there. Why not? Most of them are like, I didn't even know there's such things. And really where my expertise are coming or my troubleshooting skills are coming from now is from the engineering side. Because I understand more of the engineering side, it's making me help be a better troubleshooter and matching all those different things up, like from the PID to the electrical diagram, and
yeah.
just makes so much more sense. And I think that's the way more people need to, like more schools and colleges need to train is like, here's the equipment. And it's not only in refrigeration, you can do this on any piece of equipment. There's any big manufacturer like Heatcraft, they will be building an engineering drawing for it because they need to
Oh, yeah, they
understand it,
will.
right?
They
So
will.
sometimes it's hard
And
to find them though, but I'm sure if you call up the manufacturer, they'll have it for you. Because all the good
yeah.
manufacturers will be able to send it, no problem.
And to your point, we're doing more and more of that as far as providing those, because see, you have so many layers now, because see, you've got the controls layer because that's low voltage, but then now you've got VFDs that are running those motors and many times the compressors, right? So that's another layer that has to be called out and found on a diagram somewhere to see where they all match. And then, well, which controller, which pressure transducer is responsible for that part of the circuit, you know? So I look at it this way. It's like the old adage about, well, if you look at the whole thing, it might be really overwhelming, like an elephant. Well, how do you eat an elephant? One bite at a time. Just look at it a bite at a time and just work your way through it. Don't just look at the whole elephant. Where do I start? Do I start here? There? I don't know where to start. No, we want to just one bite at a time and work through it that way. So just layer by layer, and you'll find the root cause of why you're there in the first place, right?
And I think that's the thing. Even when I was a younger apprentice, I used to get really overwhelmed because I didn't know what I was doing. I wasn't really taught. So I'd get into a rack room and you see all these valves and all these wires and nothing labeled. No, didn't know there was diagrams that I could even go look at, and compare to. And it just took me so much longer to troubleshoot, more stress in my life. And then now I know where to go. You go and you look at the drawings. Could they have changed? For sure, if there was renos and things changed over time, but
Oh yeah.
you get somewhere to start, a starting point. And when you can put them together, and this is
Yeah.
what I love, like you said, seeing people, the light bulb hit off, you can see it happen when they're looking at the piping diagram and the electrical diagram. Oh, that solenoid goes to there, that back to that control relay board. Oh man. So when
Yeah.
that opens up, when that temperature hits that high, this opens this. It's like, oh man, amazing. It's magic.
Yeah. Magic.
Magic. Oh man, I love it. I love it. So you're working on this program that sounds super exciting. I wish I was actually there for the beta test. That would have been a lot of fun. Now, so what's the next step? So you're going to do a beta test now, but so what's the plan? Mid next year, fall of next year, trying to get a full out program? I'm not sure, what's the plan?
Well, we really hope that by Q2 of next year, we'll have a full-blown a course, 2 steps. Remember, step 1, the opening step, or level 1 training for those who just are familiar with just want to get familiar with just troubleshooting, not troubleshooting, but just starting a system.
Yeah.
Because there's the way you have to, even when it comes to charging the system, after I always stress having a system clean, dry, and tight, right? Clean, dry, and tight seal system. once that's confirmed, right?
Yeah.
Clean, dry, and tight.
Yeah.
That's how we run, right? See, so once you do that, what is the proper way of filling a CO2 system with CO2? I mean, am I going to use liquid? Am I going to use vapor? What kind of tools do I need? I can't use a standard manifold gauge set because I'm talking about high pressure. So I've got to use another manifold gauge specifically for CO2. And what is that going to look like? And so what of the tools of the trade am I going to have to add to my toolkit to do a successful job at doing this CO2 wise, and just again, safety is a big thing, but also making sure that they understand why even the materials for constructing a seal system, the piping is different. So yeah, you can use copper to a certain extent, but it's got to be of the type that's got a little iron in it, so it's not the same stuff
Yeah.
as you used maybe for HFC systems before. So understanding those things and the type of acceptable brazing alloys you can use, that's part of it as well. Just as a refresher, we don't have enough time to actually teach from scratch because it's not a trade school
Yeah. Yeah.
from scratch how to do these things.
Yeah.
But having those nice reminders there is a plus. And of course, we want to be there for them when those hands raised for those kind of questions to be asked.
Yeah.
We hope to have the answers for them. Yeah.
And I like what you said there, though, like clean, dry, and tight. I think that's the most important thing in any system, but I'm seeing it done more in the CO2 system because a lot of people are cautious about it, and the systems they do cost a bit more now because you got more electronics on it than it was. Even the blend systems are all coming electronics now, so they're costing more as well. But is that initial step when you start up a commission, and start up. I think that's the most important. When that is done right, that system's going to last a long, long time. And Absolutely. I think over the years, it's just, I've even seen me install many systems that was not done right. You got to have it up and run tomorrow, 60 feet. 60 feet of cases until tomorrow. Like we didn't even start piping. And you want to, and then you got to pull all the other ones out too. It's like,
yeah. So the demo work on top of that, right?
So it's I think customers too are starting to understand that not all of them, and I hear lots of different things, but a lot of them are speccing it. We want to see it sitting there for 24 hours. You know what I mean? Pressure test or evacuation, and making sure it's holding those amount of times that are recommended. And these procedures that should have been done with the HFC systems are now just being done with the CO2 systems, and the less corners are being cut, which I can see from some of definitely the contractors here in Canada, they're doing it right. The ones that I've been working with and seeing.
That's great.
That
is great.
And when I talk to them, they say they're telling me how they're doing it, and the processes they're doing. I'm like, well, that's almost to the book of what the manufacturer recommend. And a lot of the times, sometimes there's like little gray areas, but they're trying to make sure that those pressures are held. You're not having any leaks, because that's the big one. If you have a little leak and you don't tell, you pull evacuation, you're sucking in contaminants. Even though if you pull it down deep, maybe there's that little tiny leak somewhere. If you don't let it sit there long enough to see if your microns go over 500 or whatever, because if you only let it sit there for an hour, it might take 2.5 hours for those microns to show if it's at a different spot, right? So it's that initial startup. I really like that.
Yeah, and then if people allow enough time, a lot of times, of course, there's no one reason why some of the corners are cut, like you just mentioned.
Yeah.
Because sometimes people are under the gun by their employer. Okay, so, well, I've got 10 more calls after this to make. Do I really need to take the time to do it right? Sometimes you make them mop themselves in the corner, so to speak. And so we hope that the industry in general can understand that there's certain things that must be done, and those things take time. Now, granted, if you have a well-trained staff, then you can kind of cut down the amount of time for each particular task to be done. But the total time needs to be the total time. I mean, it is what it is as far as that's concerned. Like you mentioned, that 24-hour period where you're looking, okay, so what's my follow-up specification for that? Am I really going to stay within the allotted amount of microns as far as how dry that system needs to be or not? Those things can't be rushed. The time is the time.
Yeah,
the
I
times of
know.
time. So if
And
you,
I've seen it. I've seen it before. Like even on units that I was doing, trainers that I worked on, is like I could pull it down to 500 microns, no problem. It says it on the gauge, 300 microns, but doesn't mean there's not moisture in the system because I let it sit there for 2 hours and I come back and it's 800. Oh
see,
well, we'll just let her go. Let's rip her up anyway. But that's when contaminants happen and the breakdown starts to happen over time because a lot of people don't understand, and I didn't even understand, is that like if you got moisture in the system, well, it won't kill a compressor today. Maybe it won't be tomorrow. Maybe not next week. But it could be 3 years down the road because of my installation on day one, that first day one. Oh, it's below 2,000 microns. It's okay. I've done our 22 systems that it was good at 2,000 microns.
you just robbed some life from that system. So you made its life cycle even less, So I used to take this use this illustration back in the day, the old Sears cold spot chest freezers. I worked on one time, was a 1949 model. And old cold spot, that was before they had Kenmore, right? It was cold spot, right? The only thing wrong with that system after all that time was the cold control had a burn off wire. I say this for a reason. Back in the day, they did that seal system right. Yes, it was all steel, but it was clean, dry, and tight. The compressor was still running because you just think, I mean, it's just a magnetic field, right? What's to wear out about a magnetic field? If you don't have contaminants that are eating away at that varnish, if
Yeah.
everything is nice and clean inside that system, it can run for decades. There's nothing to stop it from doing that if you do it right initially. But to your point, if you don't, you just rob some life from that system. It's going to eat away at its innards, so to speak, and it's going to fail. And it will be a catastrophic failure when it does, right? See, so just time on the front end, will save you some grief in the future, right? So,
Yeah.
yeah.
No, I love that. I love that, Don. I love that. Okay. Well, I'm excited about you getting your program up and running. Like I'm definitely going to come and check it out at some point because it's
You have an open
I
invitation. I told you
appreciate
that
that.
already. You
Yeah.
can come,
I
see the
know.
R&D center, and just do the whole shoot match. Maybe at ASHRAE you can do that. Okay.
Yeah, maybe that'd be awesome.
Yeah.
Um, anything else? Anything else you want to let the audience know? Because I know we can go on and on here, but is there any other things about CO2 that you'd like to mention to the audience or any of your customers out there? Definitely got to head to the website to check out this. How could people? What's going to be the process to get into these certified programs? Are they going to be able to go to your website to be able to find
A-
to register?
Absolutely. Just our general website, heatcraftrpd.com/training. You go right there and you can see a whole synopsis of our training. We have something called Heatcraft TV that has some nice videos, just quick instructional videos about things. Like to your point, well, what's this about micron gauges, or why are there different ratings for even multimeters? Those kinds of things. What is a rating with the number 3 behind it mean, or a number 2 or a number 5 behind it? What does that mean? So those and then how about refrigerant blends? What makes one a zeotropic as opposed to a azeotropic blend? All those things are right there on the website, and really quick. They're nice, digestible little chunks of information that can be useful. What makes a transducer work the way it does? So we use a capacitive type transducer, but there's a nice 3-minute video about transducers right there on the website. So, but then that about training and training opportunities, that's what's going to be posted on the website there. And there's going to be also a synopsis about, well, what does this training involve? So what will you learn? How will you learn it? And in what format are you going to learn it? So is it going to be lecture? Is it going to be some hands-on? Is it going to be a mixture of the two? So it'll give you a nice a taste of what you can expect if you actually attend the class. So then you can register right there for the classes as well. Yeah.
Oh, I love it. Don,
Yeah.
thank you so much for sharing your knowledge with us and taking the time to speak with me about training. And I really appreciate it. And I'm excited. Hopefully, I'll see you when I'm in Atlanta for sure.
It's my pleasure. And we're going to make sure that happens, Trevor. Okay.
Awesome. Thank you so much. Have a great day, everyone.
All right. Take care, everybody.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.